Hello, my name is Anshu Kesarwani and I work with Revit Technical Support. Today we'll be learning about pinning and pre-populating a storage LUN presented via SteelFusion. Let's have an overview first. LUN pinning and pre-population are two separate features configured through the core that together determine how block data is kept in the block store on the edge. Before we get into details, let's first understand what is pinning and what is a pinned LUN and how different is that from an unpinned LUN. With an unpinned LUN, we cannot guarantee that your block would always be available on the edge. With pinning, edge allocates the block store space, which is equal to the size of the data center LUN. If we just enable pinning, it only reserves space but does not populate. It is done later via the server read requests or via the pre-pop operation, which we'll be discussing later. So what it essentially ensures is to prevent the least recently used eviction of these blocks. What are the use cases for this pinning? Let's say in our LUNs, we are having a file system format which is unknown. Like we have intelligent prefetch mechanisms for the file systems like NTFS or VMFS for that matter. But what if I'm going to use ext3 for which we don't have that intelligent prefetch mechanisms? So we can use pinning. Or assuming a case where my application needs fast access to the data regardless of the WAN health. What that essentially mean is even if my WAN is down, my block store is still able to serve the data. So what is pre-population? So this feature is used in conjunction with pinning. It is only available after we enable pinning. So pre-population enables to prefetch blocks to the block store. The options available to pre-pop are enabled immediately or via the pre-pop schedule. How do we configure pinning and pre-population? This feature is also enabled on the core and this is pushed to the edge. One thing to note as earlier, we need to make sure that we have enough space on the edge block store to accommodate the pinned LUN, else it will result in an error. So this can be done on the GUI, which is on the LUN configuration page, or it can also be done via the CLI command, which is mentioned on the screen. Only when the LUN is pinned, the pre-population settings are activated for configuration. Let's do a quick demo. So in this demo, we can see my edge is connected to the core. Edge is already having two of the LUNs. One is 30 gig and the other one is 3.52 gig. Both of my LUNs are not pinned. Okay, let's go ahead and enable pinning. We go to configure LUNs. Go to pinning and pre-population. So if you see, my pre-pop is disabled because my LUN is unpinned. Okay, let's go ahead and enable. Okay, the moment I mark this LUN as pin, I can add a pre-pop schedule. Okay, so right now my pre-population is disabled. So let's go ahead and enable pre-population and immediate pre-population in the schedule, or I can add a custom pre-pop schedule because it would start pre-populating now if you have bandwidth consideration. So you can add a pre-pop schedule. So one of my LUN is already pre-populated, which is fine. Let's try to add another LUN for pinning. So if you see here, so it immediately pops an error to me stating that block store doesn't have enough space. Space available is 2.713 and the LUN that I'm trying to pin is 3.516 gigabits because on the edge I need to have the exact size available in my block store, which in this case I don't have. So that means it is giving me an error that I cannot enable pinning. So let's leave it unpinned. Okay. So if you see, so my OS LUN is pinned, it is caching data. So this is a 30 gig and till now we have already cached 780.1 MBs from it because I have enabled the pre-population for this LUN. So this concludes the presentation. Thank you for watching.